Hello, everyone, and welcome to the unit focusing on the vehicle conversion or vehicle retrofitting, which is part of the training course on electric vehicles brought to you by the Smart Energy Solutions for Africa or CESA project. My name is Juan Carriquiri, and I'm a part of the Urban Electric Mobility Initiative team. In this unit, you will learn first the general vehicle retrofitting definition, followed by some considerations regarding fuel-based vehicle to electric vehicle retrofitting. After the conceptual introduction, the sizing of the main components is shown, presenting two different methods to carry out such activity. Then, electric vehicle main components selection is presented, considering the previously defined size of components. Finally, a comprehensive step-by-step conversion procedure is presented to finalize the presentation. Let's have a general vehicle retrofitting definition. Vehicle retrofitting refers to the process of upgrading or modifying existing vehicles to enhance their performance, functionality, or environmental sustainability. It involves incorporating new technologies, components, or systems into the vehicle's existing structure, thereby transforming it to meet changing standards, regulations, or user requirements. Retrofitting can include various aspects such as improving fuel efficiency, advanced safety features, upgrading communication systems, or converting vehicles to alternative energy sources. Now, some fundamental considerations must be presented about fuel-based to electric vehicle retrofitting. Fuel to electric retrofitting refers to the transformation of a traditional gasoline powered vehicle into an electric vehicle or EV by replacing its internal combustion engine ICE and related components with an electric motor, battery pack, and associated items. It involves removing the gasoline engine, fuel tank, and exhaust system and installing an electric motor, high-capacity batteries, a power unit, and other necessary components. Some conversion uses the same gearbox from the conventional vehicle, while some selects the single reducer gearbox depending on the different user requirements. Fuel-based to electric vehicle retrofitting may include integrating regenerative braking systems, charging infrastructure, and updated electronic controls to ensure proper functionality and safety. The objective of this is to enable the vehicle to operate solely on electricity, reducing reliance on fossil fuels and contributing to a more sustainable transportation system. Let's now comment how should be done the sizing of the main components. The main components to be sized are the electric motor, that is the machine that converts electric into mechanical energy to move the vehicle. The battery pack, which is the device that stores the energy for the movement. Power electronics, that include components like inverters, converters, and controllers that manage the flow of electricity between the battery pack and the electric motor. The onboard charger OBC that converts external AC power into DC power to charge the battery pack. Then the vehicle control unit, VCU. It's the brain of the electric vehicles, coordinating various systems and subsystems. It manages the power flow, controls the motor, monitors the battery status, and interfaces with the vehicle's user interface and other onboard systems. And finally, the charging port, which is the port where the electric vehicle is connected to a charging station or power source to charge the battery pack. Now let's see two methods to size the electric vehicle components. The first one is the modeling by using a proper software such as the Shitty Suites, a trademark, the AVL, another trademark, or another software. The second method is by using equations considering the main vehicle variables and performance requirements. Modeling by using a specific software requires a medium or high level of engineering knowledge and must be applied for medium or big projects. On the right hand of the screen, you can see an AVL print screen where all the vehicle components are represented and modeled and must be validated before the simulations. Then, modeling by using equations doesn't require any software. It is the simplest method and it's used for small projects. In this method, the main vehicle characteristics are required, such as the frontal area, the front and rear wheels coefficient of friction, aerodynamic drag coefficient linked to the vehicle shape, the vehicle mass, and the transmission relation. It is the shear force. Additionally, the maximum acceleration, the maximum climbing capacity, and the maximum speed must be previously defined to be inserted into the equations. On the right side of the screen, the free body diagram with the forces acting on the vehicle is presented. There, you will be able to recognize three main forces. First, the weight force in the center of the vehicle. Second, the friction on wheels. And third, the aerodynamic drag force. By considering these forces and considering the power of the motor must provide to accelerate the vehicle, the presented equation on the left hand of your screen includes all the variables to be considered for, for three design conditions to be covered. First, maximum acceleration. Second, maximum climbing capacity. And third, the maximum speed. Based, based on the above calculation and simulation results, the right side drivetrain and battery pack should be selected. In this slide, an electric vehicle main components and energy flow diagram is presented. There, it is possible to identify the main components to be selected once the sizing is done. These components are the electric motor, the battery pack, the inverter, the vehicle control unit, and the onboard charger. Other secondary components such as the DC-DC converter and other peripherals must be also selected. Having done the component selection, the step-by-step conversion would be the next. For this, it should be needed to remove the internal combustion engine and its related vehicle components such as all the engine cooling system and other minor related components. On the right hand of your screen is presented a conventional vehicle with its main powertrain components. Finally, the electric vehicle components assembly and homologation is the last step. For this purpose, the following activities should be covered. First, the electric motor and the battery installation. Second, the power electronics and control system installation. And third, the auxiliary systems and integration. It must, it must be also required a proper charging infrastructure for the vehicle. Then, commissioning, testing, and quality assurance are needed as well as compliance and certification and vehicle homologation as well. Indeed, depending on the local regulations. At the end and before using, user education and support should be implemented. I hope you had enjoyed the presentation and somehow learned the main concept. I'd really appreciate your time. Thank you very much and have a nice day.